Over the past couple of years, we've seen a massive rise in the popularity of Core XY 3D printers. It's become a bit of a marketing buzzword, but there's no denying the benefits that can come with this kinematic system. Like with anything, there's always trade-offs, with a big one being cost. While they've dropped in price in a short period of time, an entry point of $400 to $500 US can still be steep, especially for a budget hobbyist 3D printer. When I pre-ordered the original Ender 3, it was by far the best experience I'd had with a 3D printer up until that point, and some of my favorite projects were made with it. Because of this, when Creality reached out to me a couple of months ago for a printer review, I specifically requested the Ender 3 V3 SE. At the time of recording, this seems to be the cheapest of their newer printers, going for right around $200. This is roughly the same price that I paid 6 years ago for the original Ender 3, and I'm really curious to see what this entry point has to offer. So in today's video, we'll be diving into the Ender 3 V3 SE. We'll go over this printer's specs, what setup was like, how it's performed, and I'll give you my overall thoughts based on my time with it so far. So with all that being said, and without further ado, let's get right into today's video. Today's video is sponsored by PCBWay. PCBWay is your one-stop shop for PCB fabrication, 3D printing, and CNC services. Their 3D printing services include everything from FDM, SLA, SLS, and even SLM technologies. I tested out both their nylon SLS as well as aluminum SLM printing and was blown away by the results. For PCB fabrications, they offer both bare and populated boards. They even have a section for open source community projects for quickly sharing designs. Links are in the description below so that you can find out more and check out all that they have to offer. Starting with the specs, the V3 S3 is an i3 style 3D printer with a build volume of 220 by 220 by 250 millimeters. It's made up of custom aluminum profiles and injection molded parts. The largest of these injection molded parts are the top horizontal beam and the large base that everything bolts into. For motion, X and Z are using good old roller wheels, while Y uses linear rods and bearings. It comes with a magnetic flex plate for the bed that's made of a thin spring steel sheet and knockoff build tack. It ships with the Creality Sprite toolhead, a direct drive setup that was first introduced on the Ender 3 S1 that we looked at a couple of years ago. It might not be their latest design, but it's fairly tried and true. The main difference is in the housing that they've added, which gives it a sleeker look. This isn't an all-metal hot end, so you'll be limited to printing with PLA, TPU, and PETG on the lower end with the stock heat break. For leveling, this printer is rigid mounted, so there are no adjustment knobs. There is a CR touch on the toolhead for creating a mesh, and a load cell at the front left corner for automatic Z offset, which we'll touch more on later. The Z-axis is driven by a single motor, but there is another lead screw on the opposite side, along with a synchronizing belt to keep both sides aligned. On the left side of the printer's base is our power input, full-size SD card for local printing, and a USB-C port for connecting with something like Octoprint. Interfacing with the printer is done using the 3.2-inch screen on the front right of the machine. Like we typically do before powering on, I cracked open the electronics bay to see what was inside. What I found was a lot of empty space. There's a Creality branded 24-volt 350 watt PSU, a Creality branded case fan, and a fairly compact board. The MCU on the board was a GD32F303, and unlike their older boards with a fairly simple numeric naming convention, this one was much longer. All wires from the toolhead come in through a single plug and are routed to their connections using onboard traces. It is a 32-bit board, and from what I can gather, it's running some version of Marlin firmware. I couldn't find a GitHub repo for this printer, and from a forum post that I dove into, it looks like Creality has tweaked the firmware on this a bit. Hopefully they'll release the source code like they've done in the past so that they're in compliance with Marlin's license. The V3 SE came packaged nicely, and setup is pretty dang simple. The printer largely comes pre-assembled, and you'll just be attaching the top assembly to the printer's base, mounting the screen and the spool holder, then plugging in a couple of cables. The first time the printer boots, it'll have you select your language and then run through the Auto Z offset. This warms the hot end, does a cleaning routine with the nozzle on the build plate to remove any filament that may be attached, and begins probing. This process has the CR Touch deploy and make contact with the corner of the bed where the load cell is to get a height value. It then moves the nozzle over the load cell and probes it as well to calculate the offset. This is then repeated a second time before the process completes. After the Z offset is calculated, the printer then performs a 16-point mesh of the bed. Once finished, I loaded up a spool of PLA and printed out the pre-sliced Lucky Cat file that came on the SD card. This has been the test file on Creality printers for just about as long as I can remember. When the print started, I was very curious to see what the first layer looked like. Although the automatic Z offset calibration got it close, seeing the perimeter and gaps between the extrusion lines is what I would consider too far away. Well, this is the case on most build plates, but on these PC plates, even PLA sticks like superglue, so the distance that they have is almost required. Because of this, I didn't make any adjustments and just let the print continue. One thing I found extremely odd was the print temperature. This file was sliced at 190°C, which is at least 20 Celsius lower than I print PLA on any of my other machines. The print was also stringy, and based on speeds, it just felt like either no thought was put into the parameters used or it was a mistake altogether. Up until this point, the unboxing, assembly, and just setup had been a largely positive experience, but because this is the only pre-sliced test file, I think that details like this really make a big difference. Moving forward, I was ready to slice up some of my own files. On the flash drive included the Creality print slicer, but I'm almost exclusively using Orca Slicer and was happy to see that there was a profile built in. At Rocky Mountain RepRap Festival, I chatted a bit with Apulo, who was kind enough to send me a hardware kit for the TalonClaw 4, a pump action blaster that I've been very excited to build. This has a lot of printed parts in various sizes, and my plan was to use it for all test printing with the V3 SE. Given how strange the first test print went, I was curious to see how something that I sliced up would turn out. So I loaded in a spool of Polymaker's Starlight Neptune PLA and fired off a plate of parts. All parts completed, but once again there was tons of stringing and the flow seemed way too high. Upon removing this first batch of parts, a small piece of the bed came off with one of the pieces, and I saw a few other sections that were very close to tearing. I really wish that Creality had just gone with PEI on this printer. They do sell powder-coated PEI beds for this machine, and I ordered one for $11 off of AliExpress, but I swapped on a Wham Bam Flex plate for the time being so that I could continue testing. Before attempting the parts again, I ran a series of flow tests in Orca Slicer and retraction tests to try to build a profile. Once I did, I printed out 30 plus parts in various sizes over the course of the next few days with virtually zero issues. I had one single piece come loose from the bed, but other than that, it just cranked out prints. Creality claims this printer is running at 2500 for the acceleration, which might not be fast compared to many Core XYs, but if we're comparing it to the 500 that the original Ender 3 shipped with, I was fairly impressed with the speed of this machine. I don't know if input shaping is enabled in the firmware that they're running, but I didn't notice any issues with ringing using the stock Orca Slicer profile. One thing I couldn't fully get rid of was the stringing. The retraction test definitely helped, and I did play around a little bit with temperatures, but some further tuning could help with getting this dialed in even a bit further. Overall, I felt like the printed parts turned out really nice. Layers were super consistent, I had no issues with any tolerances during the assembly of the TalonClaw, and the parts seem really tough. I finished assembling this around midnight, and I gotta say that I really enjoyed printing out all the pieces and building this a lot more than I thought I would. I also heavily underestimated how powerful this thing is and just how far it can launch a dart. My first shot in the studio was awesome and terrifying all at the same time, and I can't wait to get some targets set up for this. For anyone that wants to check out this blaster, I put Apulo's affiliate link in the description, and I really can't speak enough on how fun building one of these is. So what are my thoughts on the Ender 3 V3 based on my time with it so far and using it for a fairly involved project? Well, let's start with the good. At $200, it's hard to argue with the price of this thing. The thinned extrusions and plastic base means it's certainly not the most rigid of Enders, but from a printing perspective, I saw no issues stem from this. Assembly is simple, and the Sprite toolhead is a solid one compared to many of the ones shipping on entry-level printers. Z is supported on both sides with a synchronizing belt, gets thumbs up from me, and although I'm not 100% sold on their implementation of the load cell, I do think it's a clever solution. For things I don't love, first and foremost is the bed. In 2024, there is no reason that this thing shouldn't have shipped with PEI. One could argue that the PC bed is used to make sure that a beginner has very solid adhesion, but when the trade-off is a bed that gets damaged after 2 prints in my case, it's just a joke. Second is the roller wheels. V-slot wheels are cheap and they're quiet, but for a beginner, adjusting the eccentric nut to tension them leaves too much margin for error. I left mine as is from the factory, which were way too tight, and you can already see the palm dust from them wearing. They went with linear rods for Y, and if they had done that for both Z and X, it would have been a much better choice. I'm gonna sound like a broken record, but once again, I am complaining about the beeping. Anytime you make a selection on this machine, it makes a loud beep. My dog hates it, and I have zero issues with it being there as long as you give a menu setting to disable it, which the SE does not have. Lastly, and this is less about the machine and more about the experience and the attention to detail, and it's with that test file. The test file is a company's opportunity to get the user excited. For many, it could very well be their first time printing anything. Spending just a little extra time to make sure the parameters make sense so that the print turns out as good as possible is the difference between a good and a great experience. All it took was me swapping out the bed for PEI and doing a couple of test prints before I was able to get very consistent results. After that, I quite enjoyed using the V3 SE and feel like it's a fairly capable machine for someone that's wanting to dip their toes into 3D printing. If Creality refreshed this with PEI and linear rods at the same price point and maybe installed an all-metal heat break, it would probably top the SV06 to me, or at least give it a serious run for its money. And that has been the Ender 3 V3 SE. I hope that you enjoyed this video and that I answered the majority of the questions you had about this. With reviewing so many Core XY 3D printers, it was actually a nice change to just see what is an entry point 3D printer at the very bottom looking like and what is it capable of in 2024. If you have any other questions, let me know in the comments down below and I will do my best to answer. As always, if I don't know the answer to your questions, I have no problem reaching out directly to Creality to try to get those answers for you. Also, I would love to know what your thoughts are on this printer, especially for the price point that they are asking for. On that note, don't forget to like and subscribe for more great videos. We make a video every single week, so there's always fresh content coming your way. And if you do want to support the channel further, I will have links down below in the description over to our Patreon, where there are some really awesome rewards. Huge thank you to all of our existing Patreon supporters. I appreciate each and every one of you for allowing me to come back every single week and spend more time doing what I love, which is making content for you all to enjoy. On that note, this has been Daniel from ModBot. I look forward to seeing you guys in my next video. Peace, guys.